Guys, quiet down. So let's look at phase changes. So yesterday we looked over ways heat transfers. Let's look at actually some phase changes. So recall that thermal energy is the total energy of all the particles. It's the kinetic energy plus the potential energy. All matter has thermal energy. So the potential energy will be the stored energy. The energy can be stored in the bonds between atoms. And the kinetic energy is going to be the energy of motion. All atoms are moving and vibrating unless at absolute zero. So forms of energy includes just potential and kinetic. Potential is going to be stored, and kinetic is going to be the energy of motion. So heat is the amount of thermal energy that is transferred to an object area. So heat can flow from a hot stove into the egg, or into the frying pan, and then into the egg. How would it transfer to the egg? By, I meant like what heat transfer process? What would we do yesterday? So convection is where hot things rise. Conduction is by physical touch. You can put it in the freezer. So when something is a solid, the atoms are moving and vibrating at the slowest speed. As you continue to add heat, it can eventually transition to a liquid, and the particles will start moving at medium speed. Yes. Yes. I'll explain it here in a second when I get down to it. So if you continually add heat to a solid, the atoms are locked in place and are vibrating. As you add heat to a solid, the vibrations increase and increase until eventually the atoms start being able to slide past each other. When they're still bonded and packed close together, but because they can slide and move past each other, it becomes a liquid. If you were to continue to add heat to it, they'll start sliding past each other faster and faster, while also vibrating and jiggling around, and eventually they'll be able to escape and go up into the room. That's when it becomes a gas. Does anyone know what a plasma is? So, plasma is when you take a gas and you start heating it up until it becomes so hot that the electrons are not able to keep up with the atom. That the electrons get stripped off of the atom. Can y'all name some things that are plasmas? So the sun's a plasma. The electrons have been stripped off. When you see lightning or electricity sparking, the spark is actually the electrons of atoms being thrown off, producing light. So lightning is, you're actually seeing the gas turn into a plasma. So in a solid phase, the atoms are packed closest together. There's very little energy. In a liquid, there's moderate energy, and the atoms are still very close together. But in a gas, they're considered far apart. Yes. So imagine that you're not moving, and then all of a sudden you start trying to move at 1 mile an hour. That's pretty easy, right? Now imagine you're already moving at 20 miles an hour. You're keeping up with Usain Bolt, and all of a sudden he starts running faster. How easy would it be at your top speed to increase your top speed by 1 mile an hour? It'd be pretty hard, but it'd be super easy to go from 0 to 1. So the reason why it's harder to boil something than it is to melt something is because it already has a lot of energy. And you're trying to give it enough energy to escape. Another reason is you have to give it enough energy that it'll completely leave that substance. Whereas when you melt something, you just need to give it enough energy so they'll fly behind it. So you can imagine two atoms being really close together. To turn it into a liquid, all you have to do is get them to rotate around each other. They're still bonded together. You're just enabling them to move freely. Whereas to turn it into a gas from a liquid, you have to give it enough energy that'll be able to fly out in the room. So a phase change is a change from one state of matter to another. I don't think we're going to be dealing with plasma. I need to look at the test, but I don't think we'll do plasma. Anything related to plasma. Phase changes are physical changes because it only makes up physical appearance, not chemical makeup and reversible. So during a phase change, heat energy is either absorbed or released. Heat energy is released as molecules slow down and move closer together. Heat energy is absorbed as molecules speed up and expand. Let me confirm on the test. Alright, I don't have this on the test. This is more chemistry. But we can characterize heat as either being exothermic or endothermic. Endothermic just means the heat is going into a body, while exothermic means it's leaving the system. So when you melt something, you're adding heat to the ice. So heat is going into the ice cube. So melting would be endothermic. When you're freezing something, you're pulling heat out. So heat is leaving, so we say that's exothermic. Besides plasma, let me confirm and make sure that on the test. Yeah, so it's only these. By the way, there you go. So what do you call the phase change between going from solid to liquid? Melting. What do you call the phase change when going from liquid to gas? Vaporization. Or vaporization. Not evaporation. Just vaporization or boiling. Either one's acceptable. Alright, let's go in reverse. What do you call going from gas to liquid? No. Condensation. So, like if you have a cold drink, you can see condensation going on it. It's water and the air turning into a liquid on the side of glass. And liquid to solid? Freezing. Solid to gas. So, any of y'all ever seen, and put your mask on, Michael? Nope. You can skip liquid. Have you ever played with dry ice? Does it turn into a liquid? Have you ever seen videos of dry ice? It immediately turns from a solid ice directly into a gas. So dry ice is carbon dioxide. It's what we breathe out, CO2. So all dry ice is solid CO2. And if you heat it up, it turns directly into CO2 gas. It has no liquid phase at atmospheric pressure. That's called sublimation. And to go from gas to a solid is called deposition. This will be on the test. So solid to liquid is melting, liquid to solid is freezing, liquid to gas is vaporization or boiling, gas to liquid is condensation, solid to gas is sublimation, gas to solid is deposition. During a phase change, temperature doesn't change. If you have water on an oven and you're heating it up, it'll reach a temperature of 100 degrees Celsius or 212 degrees Fahrenheit. As you continue to heat it up over a fire, it will not change temperature. So while it's boiling, it will stay at the boiling point. If you have an ice cube that is melting and you put it over a fire, that ice will stay at 0 degrees Celsius or 32 degrees Fahrenheit until it all melts. During a phase change, temperature doesn't change. What you're doing is, if temperature doesn't change, that means kinetic energy doesn't change. That means that the only thing but you're still adding energy to it. That means potential energy must be changing, and that's the configuration of the molecule. And Michael, lift your head up. So as heat is added or taken, matter can change its state or phase. I don't have endothermic or exothermic on it. We can ignore that. So melting is solid to liquid. Molecules speed up, move farther apart, and absorb heat energy. Freezing is liquid to solid. Molecules slow down, move closer together, and release heat energy. Vaporization, also known as boiling, it occurs only at the boiling point of matter. Molecules speed up and move farther apart and absorb heat energy. Evaporization occurs at all temperatures. It is a liquid to a gas that can occur at all temperatures. So what is a temperature? A temperature is the average kinetic energy. That means some molecules are moving fast, some are moving slow. Evaporization occurs when some of the faster moving molecules have enough energy to turn into a gas and reach the surface, leaving behind the slower moving ones. Condensation is gas to liquid. Molecules slow down and move closer together and release heat energy. Molecules speed up, move farther apart, and absorb heat energy during sublimation. There's dry ice. Deposition. Molecules slow down, move closer together, and release heat energy. And I believe for the test, that's all. Yes, so that would be like carbon dioxide on freezing, or not, or depositing on the poles of Mars. So Mars's atmosphere is mostly CO2, and when it gets colder at the poles on Mars, it turns the air actually turns into a solid, or starts. So my plan is tomorrow test review, Friday test. The test is going to cover our heat energy, applying those equations. I will give you the formula sheet and table. It will deal with what we discussed yesterday, the way heat transfers from one object to another, and it will include today's PowerPoint. Mostly the different phases, what is solid to liquid, and so on. I will give you a key word bank. I usually don't, but I will do it on the test. You don't have to memorize how to correctly spell sublimation. And it amazes me every year how many people put solid to liquid is deposition. Whenever solid ice turns into liquid, they guess something other than melting. Alright, here's the keyword for today. Is there any questions?